Hey, I'm going to be on a podcast here in just a minute, so I'm going to probably for like an hour. Do you need me for anything?
No, I'm troubleshooting one of the back that VPN things and setting up spare.
All right, fair enough. Yeah, I've actually been coming to the office, and most of the employees are not, but one of them just came in because they're all working from home. So I still come in because I'm the only one here anyhow.
Got it. Maybe that'll be a good beginning of the podcast there. Uh,
Yeah.
cool. All right. Well, I'll start it now.
Okay.
Hello, Terry. Welcome to the show.
Thanks. Glad to be here.
Yeah. Why don't you give us a little background on yourself and on Intellimation, your company?
Okay. Um, so I have been I think I don't well I've been doing this a long time. I actually started my career as an electrician right out of high school, and probably I really cut my teeth on controls. Was working for a contractor who was doing wiring for companies like Honeywell and Johnson Controls. So I did a bunch of that. Then I worked for several years at 3 Mile Island in their startup and test division. And from a controls perspective, it doesn't get much more complicated than that. So, um, and then and basically my fourth year apprenticeship, I decided I really didn't want to do this my entire career. So I started taking college courses at a local college. They didn't have an engineering degree program. So I ended up with a degree in physics, and I really wanted an electrical engineering one, but again, they didn't have it. So I worked on and off. I finished my degree, and pretty much out of college, founded a company called Knights Electric. It was actually the first company. And we focused on doing control wiring for Siemens was our first client, actually. So Siemens, Johnson Controls, Honeywell. This is back in the early 90s. And it was great timing to do control wiring because everything was moving from pneumatics to DDC. And much of those large branch offices had their own pneumatics guys, but they didn't have their own electricians. So it was, it was great timing. We grew that pretty quickly, all in sort of South Central PA, maybe Southeastern Pennsylvania or PA. And I think it was around like 1995. I was doing some control wiring for a very small systems integrator. This was, most of our work again was for the branch offices, but we started doing some wiring for a small integrator who was doing controls for what's that company out of Texas, CSI. One of the CSI is a company, early controls company, bought by Schneider.
Yep.
And I thought, wow, and he was like a two-man operation. So I got the idea, like, if he can do turnkey controls, then we can. And started looking for a product. This is around 95. So it was right around the era that Johnson Controls and Honeywell were getting pressure from the independent controls systems integrators, plus smaller products, right? Smaller manufacturers. And so they were looking to not lose market share. So both Honeywell and Johnson Controls started their independent distribution around that time frame. And Johnson had a program called ABCS, Authorized Building Control Specialist. So in 95, we signed up with Johnson Controls to do turnkey controls. Again, fairly good move for us because we were new to doing it, but having that brand name was really helpful. So we, and that was really the founding of Intellimation. I kept the old name, and so it was two separate companies, one doing control wiring for Johnson, Siemens, Honeywell, and the other one doing turnkey controls with Johnson Controls. That lasted for a few years until the Siemens and the Honeywells, it's hard to sort of have a company that competes with them. So they basically stopped using us for wiring, and we ended up just really specializing in doing turnkey controls. So we were doing controls up through maybe and again, Johnson Controls through maybe 2000, early 2000s, where the open protocols started to really make some ground, right? LAN and BACnet. We were doing a lot of military work, and LAN was the preferred open protocol for the military bases. So Johnson, and like all the big guys, Honeywell, Johnson, Siemens, they were not too fond of open protocols, right? They owned the market at that point, and open protocols was going to hurt them. So they weren't very fast to gain that. We started looking for other products, and we've repped. I think next was Surcon for a while. That's a LAN product. Then Distech, again, another LAN product. Eventually dropped the Johnson product line because, again, they were just slow to open systems in general. And we had Distech, and then we picked up Delta Controls as a BACnet product, because LAN and BACnet, if you know, back in that era, LAN and BACnet were, they had what they would call the protocol war that was going on, right? They, in fact, I tell people now that if I'd had to make a bet back in 2005 to 8, I would have bet that LAN was going to win the protocol wars, but that didn't happen, of course. Yeah. We thought in the early days it was a better, more interoperable protocol, more complicated. But anyhow, that didn't happen, and they pretty much fell off the rails, and BACnet came on strong, and pretty much everything's BACnet today. So,
wow.
And yeah,
that's a fascinating history. All of up until this entire time you've been talking is all before I graduated from college. So this is this is fascinating.
I figured that. I looked at your history some too, and I was like, yeah, you're one of the young guns, I guess, in the space, right?
Yeah, definitely. Cool. Well, okay, then okay, so BACnet kind of took over, and then what was the rest of the history?
So we've been a Delta Controls rep now for some time, and again, I would say 70% of our business was straight stick, systems integration, putting controls in new and existing buildings. We were doing probably 30% for ESCOs. So,
okay.
The ESCO market in Pennsylvania has been strong in the schools. So we're working for, Ameresco, Noresco, doing the controls portion of those projects. And right around 2005, this was my foray into fault detection, analytics. I actually saw a demo of Symmetrix. This was Symmetrix. There's a couple companies. If you look at 2005 era, that was to me, 2003 and 5 were the really upstart of when FDD got started.
Okay.
There was some R&D, lots of R&D out of NIST. NIST did some very early work. PN&L, the guys, Mike Bramley and Srinivas were doing some research on fault detection. And Symmetrix, there's really three, in my view, three sort of early products. And I started tracking them in 2005. The Symmetrix demo was a turning point for me. I was being a controls guy and seeing, what fault detection can do. I was convinced at that point that this is the future. But it was very expensive. In 2005, fault detection was expensive. And honestly, I didn't have a client that could afford Symmetrix back then. They were mostly focused on very large central plants or very large facilities. So,
and what
so
made
I
you
pretty
think it
much,
was the future?
Kept going. Well, it was, I could see that every BAS could benefit dramatically from having fault detection running, right? It was like, to me, it was alarming on steroids. You know, every system has problems, faults. You know that, and so having that just seemed to me to you know an excellent add-on. So pretty enamored with it, but again, didn't really have anybody who could afford it. The products were really young then, so I really didn't do much about it for at least initially. Just sort of watch the market. I think I started a spreadsheet back then on sort of tracking the products in the space. And there really were only three to begin with. Symmetrics, that at least I was aware of. Symmetrics, PackRat, and Interval Data Systems. I think that, well, Symmetrics is still around. In fact, you know, Jim Lee there is, to me, is one of the grandfathers of the space. And you know, he's somebody you should get on the podcast next.
Mm-hmm. Okay. Cool.
And then I guess we really didn't, like I said, I didn't do anything about it for a while until we started looking at products. I think one of the early products that we looked at was KGS. Actually had one of the original partners there who's actually not with them anymore, that traveled down to Philadelphia and gave us a demo. That was probably 2010, maybe 2011.
Okay.
Probably the early days for KGS.
Yeah.
There was also another product called Sci Energy out of California, one of the early products. And we were actually this was probably 2000, again, maybe 12, 13, actually signed up with them.
Oh, you did? Okay.
Yeah. Never did a project because I don't actually know what happened with them. They got bought and sold and eventually just flamed out. Actually, I think there's a product called Flywheel BI. I don't know if you've seen that one.
Mm-hmm.
That's leftover from Sci Energy.
Fascinating.
The company's changed a bit. They seem like they do more CMMS now than fault detection, but they're still out there.
Interesting. All right. Cool. So you guys, I mean, the way I understand how you've approached analytics is you said you signed up for them, but you've always been sort of independent and repping many different analytics companies, right? Is that how you've approached it?
Yeah. Even in the building automation world, we always wanted to be as vendor neutral as one can be in that space. The building automation world is, you know, one of the aspects of what I don't like is that the distribution of products is somewhat controlled. You can't just buy and use whatever you want. You have to sign up, and you have to be an authorized distributor. And so we always try to be, client focused, solution focused, and not product focused, because products evolve, right? I mean, what might be the best today isn't going to be the best 5 or 10 years from now. So even in the BAS world, I mean, we still do some building automation, and we still use Delta mostly, but sometimes it's not the right fit. So we'll use other products. I would, my transition, just to get this, it was about 2014 where I felt the product development and the pricing for fault detection had come down, and the products got better and the prices got less, that it was near going to be mainstream. So that was the year we really transitioned entirely to focus on what I'll call energy retrofit work, leveraging the new analytics platforms in lieu of doing construction or renovations. We still do a little bit of that, but it's very little. Where prior to this, that was our bread and butter work. So now in 2014 we started doing that type of work, energy retrofit work. And one of the things that we realized very early on is the data acquisition piece is troublesome, right? It's the first step, and it's not an easy step. We wanted to find a neutral, we'll call it trending appliance, right? Because all of these products leverage trended data. And if you look at the trend capabilities of a typical BAS, they're weak, right? And they vary dramatically. If you walk into a typical building today, the BAS, it's all over the place. Sometimes they're trending 5% of the points, sometimes they're trending 85% of points, but most of the time it's fairly minor. And many of them couldn't trend at the interval that you need to do good fault detection. And so we really looked for some way that we could get data out of buildings easily. And I think, and actually we landed on, I don't know if you remember, building robotics, which is now Comfy.
Yep.
But in the early days, they were building robotics.
Yep.
They had a product called Trender. I don't know if you recall that.
I used it once. Yep. Yep. I did the same exact thing as you.
Yeah.
What year would that have been? For us, it was probably 2015. I remember talking to them and starting off with
that's
that
about when it, yeah. Yeah. I think I can take credit for that product to some extent because
cool.
I had landed on their SMAP protocol from, I think, reading one of their research articles from when they were at Berkeley, and when I read it, I'm like, well, that protocol, that could, we could use that. And so I reached out to those guys because they were both came out of Berkeley. Trying to think of one of them is no longer with Comfy. The two founders there, both Berkeley PhDs. I can't think of their names now, but I reached out to them and said, look, we think there's a market for a trending device based on SMAP, and we'd like to try it. I think they sent us, a free box, and we tested it, and it worked. So they decided they were going to build a product, and they called it Trender. And I'm sure we were their first, to buy it. In fact, we probably were the only ones. We actually didn't. For most clients, they would sell the box, and it was a SaaS model. For us, we actually bought the platform, so we ran it ourselves. And we bought the boxes from them, but we ran our own SMAP server.
Okay.
And
cool.
That worked. I mean, it worked fine. I can tell you, there's still one. Well, I know one of the clients that we did a lot of data acquisition for in the early days. We put one at the Empire State Building, and it's still there. It's still there and still collecting data.
Wow.
So.
Wow, that's really cool. Yeah, I think we discovered Trender.
So if you use that, and then if you recall.
No, go ahead.
I lost you there.
Are you back? You good now?
Can you still hear me?
Yep. There's a little bit of a lag, but I think it's all right.
Yeah, that sounds good. So if you recall, in Trender, they basically, I think the venture capitalist for Comfy squashed Trender at some point in time. And that was our transition to Voltron. We were looking for another solution to replace Trender. And I had known about Voltron just from, again, following the research. And so that was our sort of our transition.
Got it. And so you were no longer independent from the standpoint of your business model, but now you're independent from kind of the open data layer was now there, so that you could then use any analytics platform you wanted to using Voltron. Is that why you guys kind of headed that direction?
So, yeah, even with Trender, right, it was a neutral data acquisition layer, and Voltron sort of was even better in that it Trender had to use their own database, and Voltron was built to be sort of modular. So I think even like today it has connectors for 5 or 6 different databases. When we first started using it, we were using it with Mongo. Then we transitioned to Crate. So it's the same Voltron box, but you can use multiple and/or multiple different databases. So we transitioned to Crate, and now we're about to transition actually to Timescale DB. Same Voltron trending device, multiple databases. We even have some at the moment that are pushing data to 2 different ones. So it's been, we're pretty excited about the potential of Voltron in general, and certainly a neutral data acquisition layer. We think that's a good move for the industry in general. And I know it's one of your LinkedIn threads sort of got into that topic.
Yeah.
And
yeah. I was just going to say, yeah, for those listeners that haven't heard of Voltron, it's an open source project out of the Pacific Northwest National Lab, and anyone can download it on GitHub and use it on their projects. And it's it sounds like what you guys do is it's some sort of gateway device that's on site, and then you also have another instance in the cloud that they're then linked to each other, so that then you can push the data to any cloud database. Is that how I understand it?
Yes, we always have an edge piece of hardware. We use an Intel NUC, industrial Intel NUC, but it'll run on almost anything. It's we consider it a little plug here for Voltron, but we like the way it's built in a modular fashion. So it has multiple drivers, right? So it talks like we typically use. It's got a backnet driver, of course. It uses back pipes. It's got an Obix driver that gets us the Niagara platform and anything that's backnet. That covers a lot of ground. It runs on Ubuntu. It's written in Python, which is a very popular language now. It uses a message bus, PubSub message bus, RabbitMQ to communicate. It's got built-in encryption. So we consider it to be a good platform. Presently, I shouldn't say that. We have most of our application for it is doing passive trending, but it does have an actuator, what they call an actuator agent, so it can write. And we see that as really future looking. We have done a few pilots with an agent or an application that PNL built called Intelligent Load Control.
Okay.
Where it does in fact write back. So we started piloting that 2 summers ago. Have you heard of that application at all?
Yeah, I've seen it, and I've been looking at it, just tracking Voltron. It sounds like throughout most of the history, but I've never used it. I've just been tracking it, but I've been tracking it lately for this grid interactive efficient building type of strategy. It just seems like it lends itself really well, and certainly just exactly the way you just described it. So, and I read about it in the newsletter a couple weeks back, and I'll definitely link to that for everyone in the show notes so they can catch up on this. But so you guys have done some pilots testing that out, it sounds like.
We did in 3 buildings 2 summers ago, and we hope to do some more pilots this summer. That was the game plan, working with PNL. We had 2 clients that were willing to let us pilot it on 3 buildings each. actually not just ILC, but another application called that they call AirCX, which stands for Automated Indication of Retuning Measures. And we're pretty excited about that application as well, because that gets into the to this topic of ASO, right? What DOE is calling ASO, Automatic System Optimization, which we think is fault detection is really great, but optimization we think is the other half of the energy savings equation, and so you have to add that into it. And AirCX is a application that will allow us to do that.
Yeah, I hadn't heard of that before. That's interesting. AirCX, and yeah, PNNL is certainly known for these types of retuning strategies, so I'll definitely check that out. But I want to dive deep into supervisory control because and optimization.
I would agree.
Yeah, let's stay on the independent data layer real quick. So let's just kind of close that out because it was one of the things that I wanted to talk to you about. So with you guys installing that and then having many different options of where you can then plug analytics into it, one of the things that I wanted to ask you about is how you tag and model that data, given that all of the different analytics platforms that you might plug into it, they all have their own data models. So how do you think about that?
Well, one of the things I guess I want to sort of our view on the value of the middleware layer is sort of akin to what BACnet is from a proprietary COM bus. If you have a standard data path, then basically you're not locking, you don't have vendor lock-in. And our industry has a bad reputation for what I call the lock 'em and loot 'em business strategy, where you get, once the vendor gets a foot in the door, they're very hard to get out. So now what makes that work? What makes that work is this tagging standard. Prior to a tagging standard, pretty much, in fact, all of the FDD products that we've used were really a proprietary mapping every time, right? You had to do a mapping process, and they had their own data model, and we're in the transition, right, between that and a standard data model. I was hoping there would be, what was it, probably almost a year and a half ago now, where you had Brick and Haystack and ASHRAE put out a press release that indicated they were going to work together to have one standard. Prior to that, it seemed like we were going to have maybe three, and that was not going to be good for the industry. I don't know that I've seen them work together a lot, but I've certainly seen pressure from Brick and I think the pressure from Brick is probably what prompted Haystack 4.0. So I don't think any of them are perfect, but we think that a standard is ideal, and it's what makes this plug and play work. And our approach at the moment is to actually tag with Haystack, although we're working with somebody right now that thinks we can cross tag. So we can tag a data set with both Haystack and Brick, because they do overlap a fair amount, right? And and then we house those tags in whatever database that we're using. Right now we're housing them in Crate, but if we transition to Timescale, we'll house them there, and then we'll have a Haystack API. So the other part of the standard is having a standard way to pull the data out. And right now the Haystack API is the best thing that we've got. And we actually wrote, for what we have now, we actually wrote a Haystack API connector. And so the theory is that if we do the data acquisition, and and have the data in a neutral database, then the client can use more than one. They can transition easily. They can switch gears if a product down 3 or 5 years from now that they want to change. They don't have to redo the entire data acquisition and tagging layer. That all stays. And it's in an open source. The beautiful thing about Voltron and those databases is so far everything is open source. So it doesn't really cost anything. There's no SaaS model to it, to that entire neutral data layer.
Got it. Okay. So if I try to summarize kind of your last 10 years of fault detection, let me try. It's basically you started using all these early adopters, basically. So it sounds like you started using Sci Energy, and well, you signed up as a partner but didn't quite use them. You use KGS, you use others, and realized that, hey, there's this part that's still proprietary, and we can basically, as the integrator, come in and install this neutral open middleware layer, or I call it open data layer sometimes. You tried out another package, but then you found Voltron, and you've been using Voltron ever since, and that allows you the flexibility to send data or pull data from any application, whether it be KGS or SkySpark or whatever, and that provides your clients with the flexibility to try out analytics packages or switch, or and it really drops the integration costs as well, essentially, right?
I would agree with you. It ought to drop it. I mean, one of the things that we do very well is the data acquisition piece. In the early part of our business, we really weren't chasing data acquisition separately. We were just doing it for ourselves, but we realized there was actually a market for that. So we've done data acquisition for a number of software companies that had software of some sorts, but didn't know how to get data out of a BAS. In fact, many of the FDD products aren't very good at getting data out of a BAS. So we think that data acquisition is almost a separate solution. I mean, we did it in the early days for Coppertree, a company called Cortex Building Intelligence, EcoRhythm, another FDD product, all just doing data acquisition for them. We weren't, we just did the data acquisition using Trender or Voltron, and it was their client. So that's a tricky part of it. We think that middleware layer does make a lot of sense, and it allows us to sort of use. In fact, we had a client very recently where we were able to quote them the data acquisition, and then give them three different options, right? SkySpark. In this case, it was SkySpark, KGS, and Coppertree. And we gave them what we thought were the pros and cons to those three products, and let them choose. They were a fairly sophisticated client, so they wanted to understand, that they had options and what those options were and what we recommended. But we let them make the final choice of what product that they wanted to use.
Got it. And we
think that's a pretty good model for larger clients.
Yeah, I mean, definitely. This model is obviously different than a lot of firms like yours and a lot of firms that I kind of grew up in, right? Where you have guys on your staff that are very skilled in one platform or another. I mean, the one that comes to mind for me is like SkySpark. Once you learn that whole ecosystem, it's you're a little bit biased in a way, because your guys have spent a long time learning it. They are obviously very skilled at it, and so that could be a little bit of a bias that works its way in. But this model where you're kind of like basically totally independent is pretty novel from my standpoint.
I agree with your comment that one of the things about SkySpark is that from our perspective, it's certainly I still think it's probably the industry leading product. but it definitely has a very heavy engineering component, right? The implementation of it is very time consuming engineering wise. And I consider that to be sort of the opposite of say a KGS, where everything is done. You're not writing any of your own rules. You're not, you're not even doing the data acquisition, or you're not doing the tagging piece. Everything is done. So it's a plug and play product. SkySpark, again, the industry leader, but I joke people, I said, this is kind of like half done, right? They built the back end,
Yeah.
but there's no rules, right? There's the user interface is weak. So in the early days of SkySpark, most people overlaid it with something else. Again, they've done successful with it, but it's very different than a KGS. And I consider Coppertree to be somewhere in the middle, right? There you can write your own rules if you want. They've made it easier though. They've abstracted the rule writing, so it's a little bit easier to use than SkySpark. But to me, one of the cool things about their product is they have a rules library that all the partners share. And so you're not reinventing the basic NIST rules every integrator, over and over and over again, which is, I think, a weak part of SkySpark, where every integrator is rewriting the standard, 80% of the rules that are the same thing for everybody.
Mm-hmm. Cool. So yeah, and I think just to kind of hit that point again is that there are a lot of SkySpark vendors that use SkySpark as the data layer, right? So it kind of, and this is what I've done in the past, is they're going to then use that as the back end, whereas you guys are using Voltron, and it opens up some more flexibility. So that's really interesting. Okay, so just to kind of finalize our independent data layer or middleware layer discussion, what right now do you see? You mentioned that the data layer or the modeling is in transition right now. So you said we're in transition to a standard data model. So what are the limitations currently when you guys are setting up this open middleware layer right now with the standard data models?
Man, what I mean by that is, I would, and this is to sort of, Nick from KDS's point, is that we're not at a place where if one person tags it, right, with one standard, that every vendor can automatically consume that information. And part of that is because, the standards aren't perfected yet. But we're certainly getting a lot closer. And I mean, even it's funny, Nick tells the story that, the first site that they did with Haystack, and Haystack, the first site they did with Haystack tags, they basically had to start over again because there is a lot of discrepancy in the way that you would tag with Haystack. It wasn't what to call it. There was nothing to force everybody to tag the same way, and so part of that is the tagging model, and then the training on how to actually tag, or having a standard tagging tool. If everybody used the same tagging tool, right, then everything would be tagged the same, even within Haystack. And we're not quite there, but I think we're getting a heck of a lot closer. Haystack 4.0 closes the gap on a bunch of their weaknesses in the past. And there are a number of tagging tools out there now. In fact, we've been sort of, hunting for the ideal, what I'll call auto tagging tool for some time, and demoing lots of products. And, it's because that's been obviously an obstacle to deploying this type of software. But I think we're at a point where if Haystack is defined well enough, the method of deploying it is defined well, that the software vendors can then create the right connection. I mean, in the perfect world, they'd be able to basically connect to with the NHaystack protocol, connect to any database that's tagged well, and there would be no onboarding, right? It would automatically work. That's the perfect world. I don't think we're quite there, but I would say we're probably 80% there.
Okay. And these tagging tools, I'm not that familiar with these tools that are popping up in this area. Is this a place where it's like a startup company that's popping up providing these tagging tools, or is Voltron heading that direction to provide that? I'm assuming what you're talking about is like machine learning algorithms that add the tags automatically based on a point name and the data that point is associated with, that kind of thing. Is that right?
That's right. And we've tagged by hand for years, and it's time consuming and painful. And it's because our industry didn't have a point naming standard. If we had one of those years ago, it wouldn't be quite so hard to add tags. But as you can imagine, every site you go into, they name things somewhat differently. So yeah, this to me, the holy grail is some kind of auto tagging. And when I say that, I mean some machine learning that uses all the metadata you can pull from a BAS. So metadata meaning the point name is always probably the most important, but you got the unit of measure, the actual present value, and the trended value. You've got typically the description field. You've got the point type field, right? So BACnet gives you a number of properties that when you scrape it, it'll give you hopefully enough information to decipher what that point is and add the tags accordingly. The work in this area has been going on for some time. Again, there's Mike Bramley at P&L has done some early work on auto tagging. United Technology Research Center, the carrier folks, they actually funded one of the early tools that we used was a project that their research center built probably 4 years ago now. With some DOE funds, so it's open source, and we got it, and it was a good start, but it wasn't finished. And then Bueno has one. It's pretty much anybody who's an analytics company. We're going to build a tagging tool, right, to just make their life easier, but it wasn't going to be a standalone one. Mm-hmm. There's a company called Onboard.io that actually. They are a startup, probably 2 years old now. I think 2 guys from KGS, 1 guy from O-Power, and they initially started up to specifically build an auto tagging tool, and they're so I know they have something. We worked with them in the early days. There's another company that we are testing out right now, which so far we think is probably the best thing we've seen. It's actually a company called Kinetic Buildings. They're out of Philly here, so they're actually a local company. PhD that came out of Drexel that actually has an entire analytics platform as well, which we're also testing, but we're really more excited about his auto tagging tool. We want to be able to use that sort of independently if we can. Mm-hmm. So, I mean, for us, I know Coppertree has built some auto tagging capabilities as well. I don't know where it is at the moment, but almost everybody has to have something like that has a product. We're just looking for something that's standalone, right? So we don't have to. It's not married to a particular product.
Right. Cool. All right. Yeah, I'll definitely check some of those out. And I have a siren coming on right now, so we'll cut that out here just a second. Let it go by. Fire truck coming by. Yeah, now it's going away. Okay, cool. So I guess I'd like to kind of transition now to supervisory control. So I'm writing this deep dive for Nexus members right now about what I see as kind of the next phase in analytics, right? It seems like you're in agreement with that. So kind of what are you seeing as far as the types of supervisory control that analytics firms are wanting to add? I know ASO you mentioned is one of them. I'm seeing that and some other applications as well, but what are you excited about in that area?
Well, we definitely think that, you know, this you know, what we call optimization, I think KGS calls opportunities for optimization, right? Their software will actually find those types of things. That's very much what AirCX does as well. So it'll basically, you know, if you, we tell you, if we walk into a typical building, things like optimal start, which is algorithms that have been around for 30 years but get deployed very infrequently. They should be deployed at, you know, in every building. Temperature and pressure resets for VAV air handler units. We see that a little more often, maybe in 15% of the buildings that we walk into where it's applicable, but not in the other 85%. So, you know, that's an optimization. Chiller plant optimization is where this, to me, this work has been going on for a long time, right? That's where it really started in chiller plants. Because if you're going to optimize one thing inside a building, if it's got a chiller plant, that's what you want to hit first. So that's fairly developed. So products like, in fact, there's a number of companies that are specialized in it. Products like Plant Pro, TechWorks, Optimum Energy, they all basically give you a Niagara Jace, right, with their optimization algorithms on them. You drop that in the building, you map across the data points for the chiller plant, and it takes supervisory control over from the BAS. So we think you can do that both on the chiller plant and on the rest of the building's HVAC equipment, so on the air side as well. And we see that sort of as the next move. And it's interesting, we saw a demo from the BrainBox AI guys, and you know, that's what they're doing. In fact, I used the term in the demo. I basically used a term that it looks like you were lobotomizing the BAS. They're literally taking control, which is what it's exactly what you know, if you look at a Plant Pro product, it's exactly what that does. It takes over the chiller plant control from the BAS. So in my view, first of all, I don't think you can take that to the cloud entirely. I think that is going to have to stay at the edge. So we've always used a heftier data collection box. So we're running on an industrial NUC because we know that, you know, intelligent demand control and optimization layers can be placed there. A lot of easy optimization is literally writing to set points, which BSs are designed for anyhow. So you can put those algorithms into an edge box or into the same Voltron box that we have there and just run those algorithms there. And it's just going to write to set points. It's going to write to the condenser water set point. It's going to write to the chill water set point, the VAV air handlers. It'll do the optimal start. So we think at least my view at the moment, that we're going to find where we are going to have this edge device that does optimization in the building. And then the cloud is still going to do some advanced algorithms, right? It's going to basically do the modeling, probably feedback some of the set points. I don't think you can run it all in the cloud. I mean, you could, but I think trying to control a building from the cloud is, I'm not sure that we're there yet in terms of the quality of the connection, right? So
yeah,
I can see a day where the PID loops and basic control is done at the controller level, right? At the equipment controller level, where now all controls are done, and the optimizations or the basic algorithms or the advanced algorithms are running at the edge on a bit of a, you know, better, PC, and then heavy machine learning, model building, advanced fault detection is done in the cloud. We think that's probably the progression.
And the cloud is then just basically pushing down the model to the edge controller, essentially.
Well, you could see, like, I'll give you an example of that. So right now, a lot of BSs can do optimal start, but their algorithms are somewhat basic. one that we've used is it basically, it does learn the recovery rate of the zone. It looks at the last 3 days recovery rate. And then we'll use the schedule and say, okay, well, now that I know my recovery rate for the last 3 days, I'll average that. It knows it's got to be up to temperature at 8 o'clock. And, the temperature has drifted, 8 degrees. So I do some math. But if you had cloud where you could look at that over any temperature range, right, from the last year, instead of the last three days, look at the weather forecast, you could have a better, more accurate optimal start time. I mean, how better? I think the basic one gets you to 80%, and the cloud one gets you the other 20.
Yeah, and something I've heard that from skeptics for this new sort of supervisory control is, I've heard engineers say, well, if the BAS had all the right supervisory control sequences anyway, the savings would be minimal. And my answer to that has been kind of bullish for this new type of supervisory control, because I haven't seen a lot of BASs that have, optimized sequences programmed. And I think if you have a solution that's specifically designed for that, it kind of makes up some of that ground. There's just so much opportunity for optimizing BASs right now.
Absolutely. In fact, I would tell people, we think the fault detection maybe gets to 40%, and the optimization gets the other 60% of the savings that are possible in a typical building. I agree with the idea that if you program, in fact, our present strategy is for optimization. We will reprogram the root BAS if we can. If it's a product we're familiar with and we can program, and we've got self-sufficient in all of the major products, Siemens, Johnson, Niagara. So when we go to optimization, presently we have two options. We'll do it in the base BAS, or we'll add an edge device. We always put a backnet router controller there anyhow, and we can put the algorithms there. It's a pretty hefty machine. So we'll put those algorithms there. We think in the future, we'll probably run them on the Voltron box.
Okay.
And the only reason that we would do that instead of reprogramming the base BAS is that it's modular and it's plug and play. We can put the algorithm in one place. I mean, even these folks that do chiller plant optimization, if they took their algorithms and they went to the BAS vendor and said, here, reprogram your root BAS to do all of this, it could probably do it. But they'd have to do that with a different vendor, different BAS at every chiller plant. Instead, put the algorithm to a single box, one time, and now that's plug and play. You can drop it in and go. And that's the reason to not reprogram all these BASs out there. Right?
Totally. Yeah, 100%. So
and I would say that I kind of agree. I'm big on the 80-20 rule. I do think that that you get 80% of the savings out of doing 20% of the basic algorithms. I mean, requiring advanced or machine learning or AI, so that gets you the other 20, which is, I'm not saying we shouldn't get that other 20, but we've got a lot of time, and there's a lot of savings we can get, like the easy savings, right?
Totally. Yeah, it's a crawl, walk, run thing for me. I've been using the words crawl, walk, run quite a bit lately with our some of our clients. Cool. So what are some of the challenges with this new wave of supervisory controls that you're seeing from the field? One of them that I've heard is that there's a lot of pride going on. So it could be pride in your existing control sequences, and that might be the design engineer that has the pride there. But then the most pride I've seen is the building operator, who takes a lot of pride in maybe running his building by hand, and if we're putting the robot in his place, he feels a little threatened and skeptical.
Yeah, we're getting into the operator training part and the operator coordination part, and I agree that we have seen operators feel threatened by the automation or this overlay. Some of it's even the fact that other people can see how their building is operating, right? So even just the fault detection piece, we sometimes see operators and BAS vendors, incumbent BAS vendors, a little worried about that. So that's just an obstacle we're going to have to overcome. And your point about operators sort of manually operating it, we see that a lot. In fact, we think that operator overrides are, I don't know, a reasonable percent of the problems out there, right? Where even if they knew what they were doing when they overrode it, they forgot about the override, right? And then it's still in place, months later when the season changes. And sometimes the overrides are really in place because they simply didn't understand the sequence of operation, or didn't think it was happening fast enough. So, and part of it is because the building may have not operated right from the start. We see a lot. I mean, we retro commission a lot of buildings, and we see errors, poor sequences of operation, poor original programming, poor commissioning. So buildings, it's not unusual to have a building that's not operating right, even though it was built 3 years ago and in theory commissioned. Yeah, I tell people it's, I tell people typically the sequence of operation, I say typically, so 80% of the time, the sequence of operation is probably one that was cut and pasted from a different job, an old job, and then reused. So it wasn't really that well thought out to begin with. And then it gets programmed by a technician sitting on a bucket in the mechanical room. And maybe he gets it right. Maybe he gets it somewhat right. And then it gets commissioned by essentially turning things on. And if nothing blows up, you're done and you're walking out the door. And that's an extreme example, but there's a lot wrong with a typical BAS implementation in most buildings.
Yeah, I like to say every building's different, but every control spec's the same.
Yeah, that's a good one. Yeah, I would agree. Yeah. So I would hope, and in fact, in the early days of doing FDD, I kept telling all the vendors, you really have to do optimization. They go, well, the owner doesn't want us to, right? They want us to be passive. And I'm like, but why? Because the BS is controlling it. I said, but it's not doing a very good job. I mean, it's just not. So you can certainly do better. So I think that that is the next move. If you look at the adoption curves for EIS, if you look at these acronyms, right? So you got BAS, we've been around 35 years. You got the EIS, which is pretty well developed as well. FDD, I think we're on the mass adoption curve there, and the ASO piece is sort of the last piece. I don't say the last piece, but it's the next piece. And we're at the very early stages there, and there's a lot of room. So we're pretty excited about that. And then if you merge in this whole DERMS concept, right, distributed energy resource management, because now you've got solar and probably batteries coming, and active demand grid connectivity. So now you need that component. So that's why you need this edge device that can sort of manage all of that as well. We see that ASO and that DERMS as sort of the next wave of technology to hit buildings.
Yeah, I have it. Just like you're saying, I have it in 3 buckets in the essay that I'm writing right now. It's traditional supervisory control, just done better, right, and more consistently. And then it's ASO, and like the old ASO was just like a trim and respond sequence, and now it's turning into more learning, prediction, and optimization, right? And then that third bucket is what the DOE calls GEB, or Grid Interactive Efficient Buildings, where you're basically taking all of the systems in and using the same learning, prediction, optimization to then cycle loads in the right way, according to what the grid needs at the time.
Yeah.
So, cool. Yeah, I think that's exactly how I'm seeing it as well. So one of the things that kind of scares me, and this is the kind of the thesis of my essay, is that I'm seeing a lot of these supervisory control solutions, but also these startups that are coming in and saying, we're going to plug this in, and you don't need to think about it very much. It's just a box that you plug in, and it's super easy to install. And the reason I'm worried about it is because it doesn't speak to the history of our industry, which is we've been trying to break down these silos and we've been trying to look at things strategically this whole time. In other words, it's not just technology, it's also the processes, it's also the people that are tied to the technology. And one of the things that worries me about that solution is they're making it sound like it's an LED light bulb, and that you just plug it in and you're good to go, right? Everything's optimized. Whereas I think what I'm hearing from you and what I've seen from your comments on LinkedIn is that it's FDD that plays a role, it's supervisor control that plays a role, but then we can't forget about the operator and the engagement of the operator and the education of the operator, or else the whole thing breaks down. Is that how you're thinking about it too?
Well, first of all, I agree that the idea that the software can just solve everything, I think it's unrealistic. And they're minimizing the complexity of all the wires and sensors and actuators that are in the field. Even the ability to simply write to a point and release it isn't seamless, right? I mean, it just isn't. We've done it. It's not. It's complicated. Sometimes it doesn't take. You're not writing at the right level, or you can't release it correctly. And then if you already have issues with the operators, where if they don't understand, you know, a sequence of op that's already running in their BAS, and you start doing more sophisticated stuff, they don't understand that. I mean, optimal start, I can't tell you how hard it is to communicate that to a typical operator who's used to a schedule that says 6 a.m., that's exactly when my fan's gonna start, at 6 a.m. When you tell them that, no, now set your schedule for when you want it to be up to temperature, he goes, well, when's it gonna start? Well, I said, it'll vary every morning. Well, they don't like that, right? They don't like that. They wanna know it's gonna start at this hour. So, and then you start to talk about, you know, models and machine learning and all that. So we definitely need to bring operators up to speed. And so, otherwise, they can just derail the whole thing, right? First of all, they're gonna, I mean, whatever. They'll just, I don't want to say sabotage, but they're not gonna be on board with it. So I think we really have to bring them on board. There's an important human aspect of this. The training piece, we're giving them all these cool technology and cool tools that are pretty complicated. So they really need to understand that. We have, so one of the, and if you look at the work that P&L started, right, this retuning training, which they have available online, and then a number of other organizations have taken that and sort of moved it forward. I think BOMA has done work with P&L's retuning, and I know CUNY, City University of New York, they have an entire building performance lab that goes out and trains operators on retuning. And a lot of that training is training them how to actually look at trend logs, right? Look at the data, understand what is going wrong. It is still human in the loop fault detection, but even our engineers who were running fault detection rules, we still like to see it. We still like to go, okay, well, I see I got this fault. Let me look at the multi-trend and sort of validate or verify. It's really helpful for most humans to simply understand what is going on, right? And when you get to AI or some sophisticated machine learning, it's really hard to understand, even for engineers, right? I mean, and we're even getting worse. So training the operator is going to be important. We actually, I think I mentioned to you, and we have a project that we got funded, CUNY and Intellimation, to build an online, what I call an online on-demand training platform for advanced building operations. So focused on all of this new technology that we're giving them, how to use it well, what it does. And we have a project that's funded over the next 3 years to sort of build that out. We're using our largest client as sort of a place to try it out with. They've got 85 operators, you know what I mean? So I think it'll be a good start. We'll be looking for industry input on some of that, I mean, it's definitely going to be helpful. So
okay.
Anybody out there who's sort of interested in contributing to the project, certainly reach out.
Yeah, and I have a link that you sent on LinkedIn that I can put in the show notes for that.
Okay.
So am I right in thinking about how, like, if we think about this conversation as kind of the past, present, and future of building analytics, it's mostly left out, the building operator, maybe except for the monitoring-based commissioning type of solutions, but I think even then, they've really been, mostly implemented by a third-party consultant who's the commissioning agent, that kind of hands the building operator a list of things they need to fix. And I think I'll speak for a lot of those people, and then they've been a little frustrated by the lack of fixing after they hand them the list, right? So how are you thinking about kind of how we move forward besides these training videos? How can software vendors and then service providers in this industry kind of think about how to be including training in their solutions?
Well, I mean, people do. The problem with it is that training's hard. Most of our industry in the past has done some sort of, in-place training where they sit down with the operator or operators and they show them how to use it one time, maybe twice, right? And then they leave, and that's typically not going to stick. It's like anybody. If you sit down at a 40-hour training class for like a week and you learn all this and you jam it in your head, and then you don't use every piece of that, and then within the next 2 or 3 weeks, 80% of it is sort of gone. So to me, the training has to be online, on demand, so they can go back to it, right? They can look at it again. They can look at it while they need it or while they're actually doing it. It's just a different way of actually training. There's a term for it, embedded training, I think sticks in my head. But we really think that's the only way that you're going to be able to get operators up to speed on this. And again, you've got to get them engaged. It's not even just training. If they're part of the process the whole time, I think they feel better about it, right? As opposed to some contractor comes in, implements something, and then does some basic training for them and turns it over to them. I think that's just not an ideal approach. So even the fact that a lot of this stuff gets sold above the operator, right? It gets sold by somebody that's the operator's boss. They really need to engage the operators early on. We even tell our like clients who we're selling that to, said, we really like to sit down with the operators, get their opinion, get their feedback, because first of all, some of them really know the buildings well, and you just want their involvement in it. So I think that just makes them feel better about the process.
Cool. Okay, so a couple more questions before we kind of wrap up. Where do work orders and the CMMS fit into all of this? Either from the fault detection standpoint, but also how does it fit with what you're doing with Voltron? And then obviously the last part of what we talked about was the building operators, which would be the connection between the fault and the building operator would be some sort of work order. So how are you thinking about that part of the stack?
I do think the asset management and computerized maintenance management is a great fit and an add-on to all this technology. And it's not in enough of them already. So I don't know if that means you have to add that feature and function set into the existing products, or simply API into a good. There's a lot of software in that space already, and so probably just an API connection to it. But there's no question the workflow ought to be, all right, I see a fault, or I find a fault, I build a work order, I validate the fault, I build a work order, it gets fixed, and then it gets closed. So there's no question that's an important part of it. It's something we haven't worked directly with, but it's certainly on my transition. So after ASO becomes CMMS or asset management, it definitely is a part that has to be added in. There's some of the products have a little bit of that already starting, right? They're adding some feature sets of that in, but it's not a full-blown one.
Yeah, Copper Tree has something that's really lightweight. Obviously, Building IQ has it as part of their stack. Yeah, but it's not like if you look at a lot of larger building owners, property managers, they have some sort of CMMS already. So to me, it's something that we need to think about from an integration standpoint. And what I've seen is that if you look at, there's a whole separate data model problem inside of those platforms, right? So everyone's calling the air handler something different depending on what platform it's in, and all the fields are filled out differently. So that's a whole other challenge. And I like how you just phrased it in terms of like, okay, let's ASO is kind of the next phase, and then maybe the CMMS is the next phase, because I agree, it's something that it's not easy to implement yet. So
I also part of what I see happening with operators is a transition from actually operating to troubleshooting and repair. Because to me, in a perfect world, when you get the automation right, you do have an automated self-driving building. And so they don't really need an operator. You need an operator to maybe change schedules and change set points. But the key is going to be keeping the sensors and the actuators working and the mechanical equipment working. So it really goes to troubleshooting and repair of that, so that you get it back to being automatic. And again, that is just training, right? So they know, I mean, that, let's face it, the fault detection, even fault detection and diagnostics, even the diagnostics only works to a point, right? It can't, you still need somebody oftentimes to go out with a meter and some tools and look at it, right, and see what the problem is. That's got to be part of the training, because getting that building back operational again, or back under automatic control, requires that those actuators and sensors all work.
Yeah, and that's where one of my clients likes to just throw the word condition-based maintenance in, and I think that's in this next phase as well, is like, how do we automate what can be automated, and then let the analytics also help us with the actual physical maintenance of our equipment. So cool. Yeah. So, okay, so as we kind of wrap up here, we're obviously, it's what, May 11th, and we're still in this global pandemic, weird times for our industry. How are you thinking about how these types of technologies can help with kind of reoccupying buildings, but also managing them in the face of an uncontrolled, at this point, virus?
Yeah. We have a little bit of exposure to that, but not a lot. We are helping one of our clients shut down buildings but maintain humidity and temperature levels within an expanded range. And of course, we're going to be saddled with then starting them back up at some point, right? And I know ASHRAE has some guidelines with regard to changes in how you might want to operate a building given the pandemic issue. More outside air, which isn't going to help the energy usage much, but we know that there's a bunch of mechanicals out there putting MERV 13 filters in, and what's the ultraviolet lights in air handler units. We see that happening. So it's definitely going to make things interesting. We also think that energy management is going to get probably even more important, because this economy is going to be a little more struggling, right? So I would hope that people are going to be interested more than ever in sort of saving as much money as they can on their energy spend. And I think there's plenty of opportunity to save money in most commercial buildings with an ROI that's sub 2 years. This technology to me is really should be deployed. I mean, we're probably at a saturation rate of, I don't know, 5% or so, and it probably needs to be 95%. So I think we'll have over the next couple of years, a nice growth path.
Cool. Yeah. And that's something, I guess, to kind of wrap a bow on all of this is that, we talk about all these different waves and we talk about 10-year plus history, but it really feels like to me that these are really, the history has been of early adopters. And now we're getting to the point where we have early adopters from the standpoint of like the entire commercial buildings fleet, right?
Yeah.
Totally. Cool. Well, this has been awesome. I think it's a good time to cut out, but I definitely want to dive deeper into some of this stuff at a future episode. Thanks so much for your time, and can't wait to connect over this stuff in the future.
You're welcome, James, and keep up the good work on LinkedIn, getting those interesting topic threads rolling.
Absolutely. Yep. Definitely plan on it. All right. Well, have a good day and have a good week.